Good morning, students. Myself, Vijay Shankar from ECE Department, Chevrolet Engineering College. Today, we are going to discuss about the examples in the second part of the 15th, that is EM wave characteristics 2. In the last class, we completed the examples of the first part of the 15th, that is EM wave characteristics 1. Okay. Let us see the examples in the electromagnetic wave characteristics 2. That is the E bar and H bar waves, electric and the magnetic field waves traveling in a free space, are normally incident on the interface with a perfect dielectric. Normal incidence, they are saying here the normal incidence on the interface with a perfect dielectric with epsilon r is equal to 3. Compute the magnitude of incident, reflected and transmitted of E bar and H bar waves at the interface. Means you have to find out the magnitude of the incident, reflected and the transmitted for the magnetic and the electric fields for the given of epsilon r is equal to 3. So two interfaces, there is a interface between the medium 1 and the medium 2, M1, I am writing here the M2. It is a medium, and here also the medium 1, and it is a medium 2. So both are, it is a dielectric, and here there is an epsilon 1, eta 1, gamma 1, and the sigma 1, and in the medium 2, epsilon 2, eta 2, gamma 2, and the sigma 2, and intrinsic impedance also there, the eta 1 and the eta 2. So these are the parameters we have in medium 1 and the medium 2. Okay. Then they're asking that to find the magnitude of the incident, reflected and the transmitted of the E bar and H bar waves at the interface. Since it is a perfect dielectric, in the medium 1 is also the dielectric 1 and the medium 2 is a dielectric 2. And they're saying it is a E bar and H bar waves traveling in a free space. So let us take it is the first one is a free space. The medium 1 you can consider it as a free space. Medium 1 is a free space. Let us take here medium 1. I'm taking it as a free space. What is the eta? Eta 1 is equal to. Okay, let us draw. Eta 1 is equal to the standard value, that is at 120 pi. 120 pi. How will you get that value? Under root of mu by the epsilon in the free space, mu r, that is a mu naught and the mu r by epsilon naught and epsilon r, both are in the free space, means the mu r is equal to 1 and epsilon r is also 1. So the mu naught by the epsilon naught. What is the mu naught? Mu naught is 4 pi into 10 to the power of minus 7, and whole divided by epsilon naught is 8.854 into 10 to the power of minus 12 into 10 to the power of minus 12. You calculate this one, you'll get the 120 pi is approximately, or intrinsic impedance is the ohms, so 377 ohms. Okay, that is in the free space. Now I need the eta 2. The eta 2 is not, the medium 2 is not in the free space. So the formula is a mu by the epsilon, that is equal to under root of mu naught and the mu r by the mu naught epsilon naught and epsilon r. See, the E bar and H bar waves traveling in a free space are normally incident on the surface interface with the perfect dialectic with epsilon r is equal to 1, epsilon r is equal to 3. Okay. Now I am taking here, it is a epsilon r is equal to 1, which is not in the free space, for pi into 10 to the power of minus 7 into 1 whole divided by 8.854 into 10 to the power of minus 12. And now the value of epsilon r is given, that is a 3. That is a eta 2 in the medium. Okay. In the medium 1, the eta 1 is equal to 377 ohms. And in the medium 2, now the eta 2 is equal to, if you calculate this value, you'll get the 217.50 ohms. Okay. It's a 217.50 ohms. Got it, my students? Now you can find out the coefficient, the transmission coefficient and the reflection coefficient. We know the transmission coefficient. Tau is equal to ET by the EI. Where ET is transmission and the incidence. And also we have the formula is there, the 2 eta 2 by eta 1 plus eta 2. So we know the eta 1 and the eta 2 for the medium 1 and the medium 2. You can substitute here 2 into 217.50 whole divided by and 377 plus 217.50. Simplify this one, we'll get the transmission coefficient is a 0.73. Similarly, the reflection coefficient in the normal instance, reflection coefficient gamma is equal to, that is ER by the EI. ER by the EI. And in terms of the intrinsic impedance, eta 2 minus eta 1 by eta 2 plus eta 1. What is the eta 2 here? 217.50 minus 377 as if it is a free space, and 217.50 plus 377, that is equal to, because it is the highest value is a minus 377 means, so negative value will get 0.2683. The reflection coefficient is over the negative value. We got the ratio. They compute the magnitude of incident, reflected and transmitted, the ratio of this one, ET by the EI or the ER by the EI is the ratio, the E bar and H bar waves at the interface. Similarly, for the magnetic field also, to find it is a magnetic field ratio, the magnitudes for the magnetic field. So magnetic means HT by the HI. HT by HI. What is a HT in terms of ET? It is ET by the ET is the transmission is the medium 2. So you can write here it is a eta 2. Whole divided by HI means EI by incidence is in the medium 1. So you can write this is a eta 1. So ET by eta 2 by EI by the eta 1, that is equal to, you can write this as ET by the eta 2 and eta 1 by the EI. So I can write the ET by the EI multiplied with eta 1 by the eta. Okay. So this denominator will get in the numerator and ET by the eta. So ET by the EI we already got as 0.73 multiplied with eta 1. What is the eta 1? 377 whole divided by 217.50. Then you'll get the magnitude of the HT by the HI is 1.2683. Okay, ET by the EI we got the 0.73 and HT by the HI is a 1.268. Similarly, for the reflection also, the HR by the HI. HR by HI is equal to, we'll get as ER by the EI. ER by the EI multiplied with ER. ER is in the, both are in the, ER and EI is both are in the medium one. We'll get the eta 1 by the eta 1. So eta 1 and eta 1 get cancelled. That is equal to HR by the HI is equal to the same value whatever we got in the ER by the EI because both are in the medium one. So 0.2683. Got it, my so the normal incidence means the incident beam like this, incidence, and there is a transmission, and the reflection is a reflection. Is a reflection, incidence, and transmission. So transmission is only in the medium 2. Whenever it is the ET by the EI or the HT by the HI, HT is in terms of ET is the ET by the eta 2, HI is EI by the eta 1. Eta 1 parameter is in the medium 1. Okay, what is friends? Coming to the next example, determine the amplitudes of reflected and the transmitted fields of electric and the magnetic at the interface of two regions. If EI is equal to, they are giving directly it is EI is equal to 1.5 millivolt per meter in the region 1 because the incidence is always in the region 1 for which epsilon R1 is equal to 8.5, mu R is equal to 1, and the conductivity is a 0. If conductivity is a 0 means definitely that is a dielectric medium only, the medium 1 and the medium 2. And saying that the region 2 is a free space now, is a free space. Region 2 is a free space, nothing but is a medium 2. Medium 2 is a free space and the medium 1 is not the free space and having the parameters epsilon 1, mu 1, sigma 1 and the eta 1 and epsilon 2, mu 2, sigma 2 and the eta. Now what is the eta 2? Eta 2 is equal to 377 ohms or 125 because it is a free space now. 125. So what they say, what they are asking that is to determine the amplitudes of the reflected and the transmitted fields for both the electric and the magnetic field, the same thing. The different values, so whatever we did in the previous example, the medium 1 is a free space there, here the medium 2 is a free space. Now we can find out the eta 1. Eta 1 is equal to under root of mu 1 by the epsilon. Mu 1 by the epsilon. What is the mu 1? 4 pi into 10 to the power of minus 7 and epsilon mu r is equal to 1 whole divided by, and they are giving that is epsilon r1 is equal. So epsilon r1 means the epsilon not always the same, 8.854 into the power of minus 12, and epsilon r1 they given 8.5. I can simplify this one. You get the eta 1 as 129.7, not the 7, it is a 22 ohms. So eta 1 is equal to 129.22 ohms. Eta 2 is equal to 377 ohms only, because it is in the free space of the medium to 377 ohms. Now, to find the transmission coefficient, to get the amplitudes of reflection and the transmission coefficient tau is equal to Et by the EI, and the ET, the other formula is there, the 2 eta 2 by the eta 1 plus eta 2. 2 eta 2, that's a 2 into 377 divided by 129.22 plus 377, and simplify this function. The transmission coefficient is 1.489. Okay, but they given that is a EI is equal. So what is the EI they given? 1.5. EI is equal to 1.5 milli, means 10 power minus 3 volts per meter. Now what is the ET is equal to? The amplitude of the ET is equal to the transmission coefficient tau into ET is equal to transmission coefficient tau into EI. What is the tau we got? Tau is 1.489, the transmission coefficient, and EI they given that is a 1.5 to the power of minus 3. The value is now the 2.23 into 10 to the power of minus 3 volts per meter. Add the EI, the ET is equal to we got. They are saying that find both the electric and the magnetic field at the interface of the two regions if EI is equal to in the region 1. Okay. Similarly, to find the reflection coefficient, ER by the EI, ER by EI is equal to. The formula is that the eta 2 minus eta 1 by eta 2 plus eta 1. What is the eta 2? 377 minus 129.22 divided by 377 plus 129.22. So 377 is a positive value. Now you'll get the reflection coefficient is a positive. It is a 4.489. 0.489. But what is the EI given? But EI is equal to EI is equal to 1.5 into 10 to the power of minus 3 volts per meter. Therefore, the ER is equal to 1.5 into 10 to the power of minus 3 multiplied with the reflection coefficient as a 0.489. So what is the ER when the EI is equal to means? The value is a 0.734 milli 10 to the power of minus 3 volts per meter. So we got the ET and the ER when the given the EI is equal. Similarly for the magnetic field also. What is the magnetic field? HT is equal to, we need only the HT. HT is equal to ET by eta 2. So what is the ET? We got the ET is equal to 2.23 into 10 to the power of minus 3 divided with the eta 2 is 377. That is equal to 5.925 micro 10 power of minus 6 ampere per meter. And similarly for the HR also, the HR is equal to, what is the HR now? The HR is different. If it is a positive of ER here, HR is a negative input. The HR by minus eta 1. So HR we got, not the HR, sorry. Is not the HR, ER. ER by the eta 1. Okay. What is the ER we got? 0.734 into 10 power of minus 3 divided with minus of 129.22. So what is the value? The minus of 5.681. What minus? We got for EI already given, the ET and the ER, similarly the HT and the HR for both the magnetic and electric field reflected and the transmission fields amplitudes. What it matters. And coming to the next example, an electromagnetic wave from an underwater source with perpendicular polarization is incident. With perpendicular polarization is incident on a water air. Water air means from water to the air here. Means inside, from the inside of water, and a wave is transmitted from water to the air. Nothing but we are calling it as a water air interface. Means you started at the water and ends at the air. Okay. Means the first interface is the water and the second interface is the air. What matters? To find the critical angle theta c if for fresh water epsilon r is equal to 81 and the mu r is equal to 1. They're asking the critical angle. Critical angle is a water fully is air. And here is the water. The interface between these two. Electromagnetic wave from an underwater source with perpendicular polarization. Perpendicular polarization means the electric field which is perpendicular to the incident beam. Okay. Only we are comparing with the electric field on. And similarly, the parallel polarization also, which is for the incident beam, the electric field is a parallel. So we are calling it as a parallel polarization or H polarization, that is. It's an interface between the water and the air. Then you can find the critical angle for the theta c for which the fresh water epsilon r is equal to 81 and mu r is equal to 1. What is it? Critical angle theta c is equal to sine inverse under root of epsilon 2 by the epsilon 1 is a critical angle minus is the formula for the critical angle. That is equal to sine inverse of under root of is the second medium. Second medium is epsilon naught 2 epsilon r2 whole divided by epsilon naught 1 and epsilon naught r1. So both epsilon naught is the same because 8.854 into the power of minus 12. There is no any change there. Only the saying that is the under root of epsilon r2 by the epsilon r1. See the fresh water epsilon r is equal to 81. They are saying the water 81 means the epsilon r1 is equal to 81. Sine inverse under root of, for water it is a medium 1 and air is a medium 2. Medium 2. The interface between the medium 1 and the medium 2. Epsilon r1 is a medium 1, so that is a fresh water. Epsilon r value is a 1 and here the value is a 1. So 1 by the 81. Sine inverse under root of 1 by the 81. The value is 6.38 degrees. The critical angle theta C is equal to, we got 6.38. It's a very important, the 2 marks or the 3 marks example. A simple formula for the critical angle is sine inverse under root of epsilon 2 by the epsilon. Got it, my students? And coming to the next example, a polarized wave propagates from A to the dielectric. Now they are saying here a parallel polarized wave propagates from A to dielectric at Vivostar angle of 75 degrees. Find epsilon r. See, for this you have to know that for air epsilon 1 is equal to epsilon r1 and the epsilon naught, that is equal to epsilon naught, since epsilon r1 is equal to 1. For air it is. For dielectric, because the medium between air and the dielectric, medium 1 is air and medium 2 is dielectric. Medium 2 is a dielectric. In air, always that is a epsilon r is equal to 1, and in the dielectric, that is a epsilon 2, medium 2, epsilon r2, and the epsilon naught 2 also, that is equal to, it is depends epsilon r2. So you have to find that value. Okay, and here the epsilon naught, simply epsilon r2 into epsilon naught. Got it? So Vivostar angle given. Vivostar angle is given that angle, and it is represented as theta p. That angle is 75 degrees. So what is the Vivostar angle? Theta p is equal to the tan inverse epsilon 2 by the epsilon 1. So remember that the critical angle is sine inverse under root of epsilon 2 by the epsilon 1. The same thing, critical angle. But the Vivostar angle is the theta b is a tan inverse under root of epsilon 2 by the epsilon. So tan inverse under root of epsilon 2 means in the start medium 2. You have to find here itself this one. What is the epsilon r2? Epsilon r1 is equal to 1 or, because it is a air free space. Epsilon r2 and the epsilon naught, and divided with epsilon r and the epsilon naught 1 is a 1 only. Epsilon r1 and the epsilon naught. R1 value is a 1, and epsilon naught and epsilon naught get cancelled. It is equal to tan inverse under root of epsilon r2 by epsilon r1 is equal to 1. Okay, so tan theta b is equal to under root of epsilon r2. we need for epsilon under root of epsilon R2 is equal to tan inverse tan theta tan 75 degrees. So theta B is given tan 75 degrees. What is the tan 75 degrees? 3.73. Therefore, epsilon R2 is equal to, it is a, here the square is there, both square root squaring on both sides, 3.73 whole square. That is becomes of 13 point approximately 93. So epsilon R2 is equal to 13.93. Got it, my students? Okay, in a parallel polarized wave propagates from air to the dielectric. Air is a medium 1 and dielectric is a medium. We know in the air always epsilon R is equal to 1, and we need to find the epsilon R in the dielectric for the given Vivostar angle. What is the Vivostar angle formula? The theta B is equal to tan inverse under root of epsilon 2 by the epsilon. Epsilon 2 is a medium 2 in the dielectric itself. How to know only how to find out the epsilon R there. And epsilon 1 is a medium 1. In that epsilon naught is always common in both the mediums. Epsilon R1 is equal to 1. So you'll get the tan inverse epsilon R2 by the 1. Simplify that. Epsilon R is equal to 13.93. What, my students? We got epsilon R is equal to 13.93. And coming to the next example, find the skin depth. Find the skin depth. Skin depth means it is a delta, and surface resistance, skin depth and surface resistance of a copper conductor at 100 megahertz having conductivity sigma is equal to 5.8 into 10 to the power of 7 ohms per meter, and mu r is equal to 100. So the given the values is given the copper conductor at 100 megahertz. 100 megahertz is given means the frequency is given. Let us write that one. 100 into 10 to the power of mega is a 6 hertz, and mu r is given, that is 100, and the conductivity is also given 5.8 into 10 to the power of 7 ohms per meter, and we need to find the skin depth and the surface resistance. Skin depth delta is equal to, skin depth delta is equal to, I already told that is a delta is equal to 1 by alpha. Alpha is equal to under root of, whenever if it is in the gamma is equal to j omega mu into sigma plus j omega epsilon. Whenever the conducting medium is a copper conductor, having the conductivity value is more means only we have the conductivity. There is no any dielectric. So the propagation constant j omega mu into sigma plus j omega epsilon. The conductivity is very much high compared to the dielectric, that the formula becomes j omega mu into sigma. J omega mu into sigma. So in this, the function, the conductivity, the propagation constant, and related to the intrinsic impedance. The intrinsic impedance eta is equal to under root of j omega mu by sigma is a multiplication, and here the sigma is okay, madam. But what is a delta? Whenever if it is a conducting, both are is the same, and gamma is equal to alpha plus j omega 1 by alpha or 1 by the beta. The formula is now we get as skin depth is omega mu into sigma. Is a formula for the skin depth. So remember my students. And under root of 2 by omega is a 2 pi f, where f is 100, mega is a 10 power 6, and mu into mu r is also given the 100, that is a 4 pi into 10 to the power of minus 7 is a mu naught, and mu r is a 100, and sigma is also given the 5.8 into 10 power 7. Got it, my dear students? Now you can simplify this total value to get the skin depth, that is 6.608 into 10 to the power of minus 7 meters. This is the skin depth of delta. Delta is equal to 2 by omega mu sigma by 2. In the perfect dialectic, gamma is equal to alpha plus I beta. That alpha is under root of omega mu sigma by 2 plus j into under root of omega mu sigma by the 2. Okay, that is nothing but 1 by root 2 under root of omega mu sigma plus j into 1 by root 2 under root of omega mu sigma. These are nothing but, what is a 1 by root 2 and 1 by root 2? In the both the function, there is a common term is under root of omega mu sigma, and multiplied with 1 by root 2 plus j into 1 by root. What is a 1 by root 2 into j into 1 by root 2? Nothing but here it is a value of angle 45 degrees. So gamma is equal to under root of omega mu sigma, and this value is cos 45 degrees plus j sin 45 degrees with an angle of 45 degrees. Okay, and this angle you can write as under root of j and under root of omega mu sigma. J means the one angle with 90 degrees. Under root is the one angle with 45 degrees. Okay. Therefore, gamma is equal to, you can write is j is also inside, j omega mu sigma is what we have here. Okay. Like that, so we'll get the delta is equal to, what is the delta I told? 1 by alpha or 1 by beta. 1 by alpha or 1 by beta. What is alpha here? Now, alpha is equal, what is alpha? Omega mu sigma by 2. The reverse, it is under root of 2 by omega mu sigma. Here the skin depth. The other thing they are asking that the surface resistance. What is the surface resistance? RS. Surface resistance is RS is equal to RES, R suffix S. Surface resistance. Sorry. I will write here. RS is equal to, the formula is 1 by, in terms of the delta into sigma. RS is equal to delta into sigma. There is a surface reactance and the surface resistance. Both are in the surface impedance. Surface impedance is nothing but eta only. Surface impedance ZS is equal to eta. This is ZS. ZS is equal to under root of j omega mu sigma, and that j we can write as a one angle with 45 degrees, omega mu by 2 sigma. Okay, omega mu by the 2 sigma, that is related to as it is also equal to the under root of omega mu by 2 sigma. Okay, you can write the sigma is here, omega mu sigma 2 by the omega mu sigma means it is a delta. So they related as 1 by delta into sigma. So both are the equal. Got it, my dear students? That ZS having one term as ZS is equal to that ZS is equal to RS plus J into XS, surface reactance and surface resistance. Same thing, under root of J you can write as 1 by root 2 plus J into 1 by root 2. It becomes of omega mu sigma into 2, 1 by under root 2, and the same. So R is the surface resistance, not the surface resistance. RS is equal to 1 by delta into sigma. 1 by delta we got as 6.608 into 10 to the power of minus 7 multiplied with sigma. What is the sigma? Is given 5.8 into 5.8 into 10 to the power of minus 7. Okay. Now use the calculator and find the RS is equal to, the value of RS is 0.02, 0.026 ohms the resistance. RS is equal, and the delta skin depth is equal. Got it, my dear students? So again, I will tell that is the eta and the surface impedance is both are the same. The intrinsic impedance and this is surface impedance. So I will write this as ZS is equal to as of under root of J and under root of omega mu sig by the sigma. What is under root of J? Is 1 by root 2 plus 1 J into 1 by root 2. So omega mu by sigma 2 into sigma plus J into omega mu by 2 into sigma. Okay. That RS is equal to omega mu by 2 into sigma. What is the delta actually? Sigma you can write here and write this here the sigma square. That is equal to under root of omega mu sigma in the numerator. I wrote here the 2 and under root of 1 by the sigma square, and the root under sigma is get cancelled. Omega mu by sigma into 2 is inverse of delta 1. That is equal to, it is 1 by delta, and the root and the square is get cancelled. 1 by delta sigma. The RS is equal. It's a very important formula, my students. Got it?